Good day to everyone. Today we are going to talk about one of the most important material behavior in the structures, that's called the stress strain. So before that, I think we all need to understand what are the material behavior which we considered in the engineering. One is the elastic. The second one is plastic. The third one is elastoplastic. Before that, when you apply the load, so this is stress and strain. So we will be talking in a while what do you mean by the stress and strain. But before that, we need to understand what is this elastic and the plastic and elastoplastic behavior. For example, in the steel behavior, we take it as like this. So here you can see the forces which applies to the distance deformation is linear. So when the gradient is constant, we call the elastic. So then we call, in other word, the stiffness of this element and the material is constant, we call it as elastic behavior. So beyond that, there can be a different type of behavior, especially when you take concrete, right? Maybe the linear part, probably initial part you can name it as a linear, but if the gradients, the tan theta is not a constant, so we can define it as a plastic. So what do you mean by the elastoplastic? There are certain material, right, which goes like this and it's behave like this. So the initial part, probably the elastic, and after that it's plastic. So steel is the best example for that. Before that, quickly we will go for the stress strain behavior. What do you mean by the stress strain? You have an element which is fixed somewhere, you apply the load, so then once you apply the load, the deformation is delta. This delta divided by original length is called sigma, and the F over A is defined by the stress. So it means the stress is defined as a unit load, the load applied for the unit area. So the stress is the elongation or the deformation, so whatever you know is a proportions to the original length. So when you talk about these two axes, right, so we call it sigma. In other words, sigma is a delta over original length. Here F over A, that is called sigma. Let's see few materials. One is the we can consider steel. Steel we assume like this. So the initial part we call this is elastic behavior. This is plastic behavior. Let's say the concrete, confined concrete. So it's like this. Maybe this is not exactly the linear, but we considered the initial. If you there's one called the secant modulus that we will talk in another lecture. So when you draw the 0.002, the angle parallel to this axis, so that theta is called the stiffness of the concrete. So this is how you define the stress strain in the material. Why you need this one? Especially when you design the structures comes to the ultimate strain. What do you mean by ultimate strain? So this is the ultimate strain. So this is the yield strain. Yield is the place which turn elastic to plastic. What do you mean by the ultimate stress? Ultimate stress, right? Now today we learn about the elastic material, plastic material. What do you mean by the elastoplastic material? Stress, strain, the behavior of the concrete, behavior of the steel, etc. So if you haven't subscribed our video YouTube channel, please do right now. And if you need any individual classes or the group classes for the international student, please contact us through this contact number. Thank you very much and hope to see you in next video.